Hello Algebra 1. In this video lesson we're going to finish with chapter 2.6 by talking about the other major topic of this section called combining like terms. Before I get into the specifics about how to do the combining, let's make sure that we understand what like terms are. The chapter does a nice job of explaining and defining them right here, where it says that in order for two terms to be like terms, they have to have the same variable, and that variable has to be raised to the same power. So, for example, 5x and negative 3x are like terms because they have the same variable x, and the exponent on that x is a 1. So you can put those together. Taking that another step forward, they say that 5x and negative x squared are not like terms. Even though they have the same variable, the same x, this one has an exponent of 1, that one has an exponent of 2. You cannot put them together. The textbook goes on to say that negative 4 and 2 are like terms. In this case, they don't have a variable, don't have an exponent on the variable. So you can put negative 4 and 2 together. And in fact, you've known since elementary school that you can put negative 4 and 2 together. One other vocabulary word to make sure everybody's clear on, and that's coefficient. I'm going to talk about these in the opposite order, these two terms. The 3y squared term, the coefficient, the coefficient is the number in front of the variable. So 3 is the coefficient on the 3y squared term. For the first term here, x, if you have a minus sign in front of anything, you can think of that as being multiplied by negative 1. So we're going to say that the coefficient on this x is negative 1. Okay, so now applying these ideas. I'll do 19, and in a minute I'm going to ask you to do 21 and 23. For 19, the like terms are the ones that have the same variable and the same exponent. And that's 4x and negative 2x and x. I'm going to ask you to hit the pause button, and when you come back, I'll show you the answers to 21 and 23. Okay, I'm going to assume that you did that. In red are the answers to 21, and circled in green are the answers to 23. Hit the pause button if you need to and look these over. Make sure you've got them right, and if you don't, come in and ask questions. Okay, carrying this idea a step further along, this is a list here, this expression, that has a mix of a number of different types of terms, and you're going to find that there are a variety of like terms in that list. Hit the pause button and see when you come back if you've got the same answer that I have. Okay, again, I'm going to assume that you did that. I ended up saying, oops, hang on just a second. Okay, sorry about that. What I meant to show you was this. I'd ended up saying that the constants were these ones circled in blue. The terms that just had a y variable I circled in green, and the ones that had an x squared I ended up circling in red. But the point that I was going to make is that you can end up then, if you want to go another step beyond that, you can pull these next to each other. And you can put the constants next to each other, the x squared terms next to each other, and the y terms next to each other. If you do that, then the next step you're going to find is that you can combine the constants and you would have gotten 1. The x squared terms you can put together if you want to, and that becomes 6x squared, and the green ones combine to make negative y. I say if you want to for all of this because the question didn't ask you to go any farther than what I've done here. I just identified what the like terms were. But logically, you would keep going and end up combining. Okay, example 5 in your textbook talks about applying the distributive property in two different directions. Example A goes in one direction, example C goes in the other. But you're going to find often that the distributive property and combining like terms are used together in solving problems. Example A is actually the opposite direction that we're used to applying the distributive property. Usually, we multiply the number on the outside times the pieces on the inside, and so if I'd multiplied that x times each of the pieces, or distributed the x to each of the pieces on the inside, each of the terms on the inside, I would have gotten 8x plus 3x. But the point they're making is you can run it the opposite way. And what you can think of doing is pulling the x, which both of these terms have in common, you can pull that out. If you do that, you've got a set of 8 and a set of 3. And in parens, you're combining the 8 and the 3 and getting 11x. Some people see combining like terms this way as an application of the distributive property. Others just say to themselves, okay, I've got 8 of these things called x. I've got another 3 of these things called x. Together I've got 11 of these things called x. And they skip this distributive property step. C runs the distributive property in the opposite direction. In this case, you do have to use the distributive property to solve the question. This 3 dangling off to the left is not going to end up coming into play until the very end of the problem. The first step that I'm going to have to take is to apply that distributive property. I'm going to have to multiply -2, or distribute that -2 to all the pieces inside. And so there it is. I'm distributing that -2 times both pieces, times the 4, and also separately times the x. And when I multiply -2 times 4, I get the -8. When I multiply times the x, I get -2x. Now, as I said, that 3 will come into play at the very end. I'm going to combine the 3 and the -8, because now I've got some like terms here that I can work with. And that becomes -5. Nothing happens with the -2x, but notice I had plus minus 2x, and cleaning it up, my final answer is going to be -5 minus 2x. This example, as I say, is straight out of the textbook, but study it, make sure you understand example 5c, and if you don't, come back and ask questions. Okay, here's a similar problem to the one I just showed you. Go ahead, once again, hit the pause button. When you come back, I'm going to show you the solution that I came up with, or actually the textbook comes up with, to this problem. Okay, I'm going to assume that you did that. First, I'll fast forward and show you the answer, and then I'll show you how that answer is built. The answer is this: 20x minus 2x minus 4x squared. Actually, that isn't even finished, is it, now that I think about it? But let's talk about how it was built. First, what they did was they distributed the 4x to both of the pieces inside these parens. And they got 4x times 5, or in other words, 20x, and they got 4x times -x, or in other words, -4x squared. Now they've got 20x minus 2x. They should have kept going, shouldn't they? And they should have put those next to each other. Yes, 20x minus 2x, but those like terms, they should have kept going and said that was 18x. So the final answer ought to have been, and that's not shown here, it ought to have been 18x minus 4x squared. Okay, another pair of problems to work with. You're going to have to both use the distributive property once again and then simplify by combining like terms. Hit the pause button. When you come back, I'll show you the answers. Okay, once again, I'm going to assume that you did that. I solved question 15 in blue here, and I came out with this answer, and I solved question 18 in red. I would encourage you. Whoops, actually I realized that I haven't shown you the full answer to the one in red. This is the full answer to the one in blue, and if that doesn't look like what you got, then come in and ask questions by all means. And do remember, at any time you can hit the pause button and study things more carefully. But let's finish up this one in red and not make the video any longer for those who do have the right answer for the one in blue. These d squared terms, notice, can be put together. Usually it makes some sense to put them next to each other. Also notice that it's okay to write plus minus as long as that doesn't become part of your final answer. So I put the d squared terms next to each other, and 15d squared combined with a -4d squared makes 11d squared. This in red here, circled in red, is the right final answer for number 18. Once again, check, make sure you've got the right answers, and if you don't, come in with questions. Moving on here now. You will often find that the distributive property and combining like terms both come into play when you're working in geometry. To find the perimeter of a shape like this, I simply add up all of the different sides. And I've put parens around each of these different sides just to kind of make it clear what each of the pieces are. But these two x's go together and make 4x. and then the remaining side, the base of that triangle, is 3x minus 5. Well, now notice the parens aren't doing anything. The parentheses are there to protect an operation that needs to happen first and needs to not be influenced by things outside. Well, there's no reason that I can't add the 4x and the 3x before subtracting off this 5. I can do that, and it's not going to cause any problems. So I can wipe away those parentheses now. And that's what I've done in this third row here. Once I do that, I see that I could put these first two terms together. The 4x and the 3x do go together, and I'm going to end up as a final answer with 7x minus 5. Here's a similar problem. Hit the pause button. When you come back, I'll show you the answer that I got. Okay, I'm going to assume that you've worked this geometry question out. Here's what I got. I put each of the 4 different sides separately, and then I realized that inside those parentheses there was no operation that I needed to protect. Once I took the parentheses away, I realized that I could move the like terms next to each other. And so, I put the ones with x in them together, and I put the constants together, and I found that I've got 3x on the left, got 15 on the right, and together I have 3x plus 15. If you didn't get that answer, come into class and ask questions about that, please. One last example, a word problem. This is actually, though, the particulars of this aren't something that happen regularly to everybody. The general idea is something that's pretty commonly faced by most people at some point along the way. So hit the pause button, read this through. Okay, I'm going to assume that you have read it. What I would do to start this problem off is I would draw myself a picture of the bar. And here's that picture. And then I would go the next step, and I would label the pieces of the bar that have numbers associated with them, or terms associated with them, I should say. So the biggest plate, the biggest weight on the bar is the x. The next one down is the x minus 5 pounds lighter than x. And then the smallest of all is the x minus 2 sets of 5. Or in other words, it's really going to be x minus 10. Now what I want you to do is write an expression that models the weights on this bar. Hit the pause button. When you come back, I'll show you what I have. Okay, I'm going to assume that you did that. Here's what I came up with. In blue, I've got the x minus 2 times 5. In red, the x minus 5. And in the green, the x. In each case, I've got 2 of them. That's why I've got 2 times the ones in blue, 2 times the ones in red, and 2 times the ones that are just the x. Notice one other thing, though. It's very easy to make this mistake. I needed to have a paren around this 2 to remind myself I'm only multiplying 2 times 5. Otherwise, you can very easily end up with a larger number than you'd intended to. Now, I'm going to distribute this 2 to everything that's in the blue. I'm going to distribute this 2 to everything that's in the red, and I'm going to, well, this 2x I don't need to do any distribution with, do I? But my task is to simplify the expression. So go ahead, hit the pause button, and tell me, simplified down, what you end up with for all of that you have here right now in all these colors. All right, I'm going to assume that you did that. Putting the blues together, I end up with 2x minus 20. The reds become 2x minus 10, and the greens that 2x. Now I can put these pieces together where I have like terms. I have like terms with the ones that have x in them, and I have like terms with the ones that are just constants. That's the answer that you should have ended up with, 6x minus 30. And if you didn't get that, come in and ask me about it. There's one more task that I want you to do. Think about what would happen if each weight was 10 pounds lighter than the previous one. Hit the pause button. When you come back, I'm going to show you what I've gotten. Okay, I'm going to assume that you did that. All that really means is that each of these 5s changes to a 10. Whoops, didn't mean to click on that. Which means, therefore, that you should have gotten this as your final answer. Hit the pause button. If you don't have the same thing, let's talk about it when you come in.